We've described a projectile with two separate equations, one for its horizontal position and one for its vertical position, both written as functions of time. But when you watch a ball fly, you don't see time. You see a shape, a curve traced in space. Let's find that curve. Here are our two equations of motion. Horizontal position grows steadily. X of t equals x naught plus Vx naught times t. Vertical position rises and then falls. Y of t equals y naught plus Vy naught times t minus 1/2 gt squared. Time is the hidden link inside both. The strategy is simple. Solve the first equation for time, then substitute that into the second. Time disappears and the relationship between y and x survives. Take that expression for time and drop it into the vertical equation everywhere t appears. Wherever the y equation had a t, we now write x minus x naught, all over Vx naught. The linear term becomes Vy naught times that fraction. The t squared term becomes 1/2 g times that same fraction squared. Notice the squared bracket. That is what will give us a parabola, an x squared term. Now expand the algebra and collect terms by powers of x. The result is a genuine parabola. The x squared term carries the coefficient minus 1/2 g over Vx naught squared. Because gravity is positive and the squared velocity is positive, this coefficient is negative, so the parabola opens downward exactly as a thrown object should arc and fall. The x term carries the coefficient gx naught over Vx naught squared plus Vi naught over Vx naught. And the constant pieces, the terms with no s, set where the curve sits. Time is gone. We have y purely as a function of x. Let's picture what this equation describes. The curve passes through the starting point, x naught and y naught. From there, the initial velocity vector leaves the launch point, carrying a horizontal piece, Vx naught, and a vertical piece, Vi naught. The path climbs, rounds over its peak, and descends. At any general point along the way, the velocity points along the tangent to the curve. On the way down, that tangent tilts below the horizontal, so the angle it makes is negative. The shape is the story. The orbit gives us more than the shape. It tells us which way the object is moving at every point. The velocity is the time derivative of position. Its horizontal part is dx dt. Its vertical part is dy dt. Let zeta be the angle the velocity makes with the positive x-axis. Then theta is the inverse tangent of Vy over Vx, which is the inverse tangent of dy dt over dx dt. But here is the key cancellation. That ratio of derivatives by the chain rule is exactly dy dx, the slope of the orbit itself. So the direction of motion is just the inverse tangent of the orbit's slope. And we already have the orbit, so we can take its slope directly. Differentiate the orbit equation with respect to x. The x squared term gives minus g over Vx naught squared times x. The linear term gives the constant gx naught over Vx naught squared plus Vi naught over Vx naught. The constants vanish. Feed that slope into the inverse tangent, and we have the direction angle theta as an explicit function of position x along the path. One important caution. The slope of the path tells you the direction the object moves, but it cannot tell you how fast. Two projectiles can trace the very same parabola while one races along it and the other crawls. The tangent line fixes the angle of the velocity, not its magnitude. To recover the speed, you need the components themselves, Vs and Vy, not just their ratio. Shape gives you heading, it does not give you speed. We can make the orbit equation much cleaner with a smart choice of origin. Put the origin right at the launch point, so x naught and y naught are both 0 at the start. Every constant term and the grx naught piece in the x coefficient drop out. What remains is beautifully compact. Y equals minus 1/2 gg over Vx naught squared times x squared plus vy naught over vx naught times x. We can write this even more familiarly using the launch speed and angle. Since Vx naught is V naught cosine theta naught and Vi naught is V naught sine theta naught, the equation becomes y equals tangent theta naught times x minus g over 2, V naught squared cosine squared theta naught times x squared. Eliminating time turned two equations into one shape, the parabola y of x. Its downward opening curvature comes from gravity. Its slope at any point gives the direction of motion, though never the speed. And anchoring the origin at the launch point strips the equation down to two clean terms. The path finally speaks for itself. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.